Hello everyone. Today we will discuss mesh or loop analysis. For discuss mesh or loop analysis, we have to know what is mesh and what is loop. If you see the circuit, this circuit can be defined by path A, B, C, D, E and F. These are the circuit points. If you see the circuit, there are many closed paths, and which is A, B, E, F, A, B, C, D, E, B, and F, E, D, F. These are the individual closed path that does not contain any other closed path or any other loop inside it. So the path or that loop that does not contain any other loop inside it, that is known as mesh. Now in this circuit there is three meshes. So if you see, there are many more paths. One path is A, B, C, D, E, F, A, or you can say A, B, E, D, F, A, or you can say B, C, D, F, E, B, or you can say A, B, C, F, A. If you count, there are total 7 closed paths. That means there are 7 loops in this circuit. So any closed path or any combination of closed path of circuit element, that is known as loop. So this is the basic concept of mesh and loop. If you see a circuit, we have to select a path in a circuit. For the sources, if we select a path from point 1 to point 2, which is connected by a battery, this battery having a source voltage E. If we go from 1 to 2, this battery polarity is plus, this battery polarity is negative, then the output voltage V will be from 1 to 2. If you see, there is fall in voltage, this voltage will be minus E. And if you select a path for 2 to 1, for 2 to 1 path, this voltage is equals to plus E. That means from 2 to 1 there is rise in voltage, and from 1 to 2 there is fall in voltage. As we select the path, and we will write the voltage of the element. Okay. Now come to the mesh or loop analysis. For mesh or loop analysis, we apply KVL in a loops, for which we have to do some steps. First step is select all meshes. If you see, there is 3 meshes. First mesh current, second mesh current, and this is third mesh current. Our first step is select all meshes. First mesh is A, B, E, F, A. Second mesh is B, C, D, E, B. Third mesh is F, E, D, F. Now second step is assume mesh current. First mesh current is I1 in clockwise. We are assuming second mesh current I2 in clockwise, and our third mesh current we are assuming I3 in clockwise. Okay. Now define branch current. If you see one branch is AB. According to assuming mesh current direction, this branch current I1 from A to B, and this branch current BC is I2 from B to C, and this branch current DF is I3 for R3. And this is the individual branches that are flowing only one current. So this current is defined by I1, I2 and I3. Now come to the branch R4. This resistance R4 carries two mesh current. I1 is flowing from B to E, and I2 is flowing from E to B. That means the net current will be the difference of these two. So if you select I1 minus I2, that means the current direction will be B to E. If you select I2 minus I1, then the current direction will be E to B. Okay, fine. Now come to the R5. In R5, the one current I1 is flowing from E to F. I1 is flowing from E to F, and I3 is flowing from F to E. That means these two currents are in opposite direction. That means the net current will be the difference of these two. If you select the net current from F to E, that means I3 minus I1. Okay. Now come to the next resistor R6. R6 having two mesh currents. One is I2. I2 is flowing from D to E. I2 is flowing from D to E, and I3 is flowing from E to D. That means that are opposite directions current. If you have to decide a current from D to E, then the net current will be I2 minus I3. That is very simple. First you have to see what are the current directions in each loop. If any circuit element carries two loops currents, if the current directions are same in a circuit, then it will be added. If the current directions are different, then it will be subtracted. And if you select any subtracted value, and direction will according to that value. Okay, fine. Now step 4, we define the polarity in each circuit element. Now come to the R1. Current always flow from higher potential to lower potential. So this is plus, this is minus. For R2, this is plus, this is minus. For R3, this is plus, this is minus. For R4, this is plus, this is minus. For R5, this is plus, this is minus. For R6, this is plus, this is minus. Now, if you see the voltage sources, you always know this is plus, this is minus, and this is plus, this is minus. Okay, so we have done all the steps. Now apply KVL in each loop. Now first apply first loop 1, that is A, B, E, F, A. That is first loop, and the KVL is from A to B. We are selecting a path A to B. Now there is fall in voltage. That means minus I1 into R1. Now B to E, there is fall in voltage. Current value is I1 minus I2 into R4. Now our next circuit element is R5. There is rise in voltage, and current value is I3 minus I1 into R5. Next element is voltage source V1, that is rise in voltage, plus V1 is equals to 0. Okay. Now loop 2 में अगर हम आए तो अपना loop 2 what is B, C, D, E, B. Write KVL equation from path B to C. There is fall in voltage and current is I2, that is minus I2 into R2. Next element is V2, there is fall in voltage, that is minus V2. Next element for path DE, that is R6, there is fall in voltage and current value is I2 minus I3 into R6. Our next element is R4 for path E to B. E to B, there is rise in voltage and the current value is I1 minus I2 into R4 is equals to 0. Now come to the loop 3. For loop 3, the path is F, E, D, F and apply KVL. F to E, there is fall in voltage and current is I3 minus I1 and the resistance is R5. Next element is R6, there is rise in voltage, current is I2 minus I3 into R6. Our next element is R3. For D to F, there is fall in voltage and current value is I3 into R3 is equals to 0. As we see, these are the KVL equation for this circuit, and if you calculate the values of I1, I2 and I3, you can find power in a circuit, or you can find any value current in a circuit or voltage across any element. This is the basic concept of mesh or loop analysis. Thank you for watching the concept. Please like and subscribe my channel.